All right. Hi, everybody. My name is Bennett Van Horn, for those who haven't met me. I'm a second-year PhD student at Oregon State University, studying under Adam Kent and Frank Tepley, who's not currently here. And this project is currently being collaborated with Michelle Coombs and Matt Lowen. And so this is, as you can see, it's very much a work in progress of just sort of a isotopic database that's mostly focusing on the Eastern Aleutians, but I'm still trying to get to the actual analyses. And so the goals of the database is it's a collaboration with the Alaska Volcano Observatory to compile a comprehensive database of isotopic data for the Aleutians. And so the isotopes of interest are strontium, neodymium, the leads, and hafnium also is going to be added somewhere along the line, and the major trace elements. And so this is going to have a primary focus on the Eastern Aleutians and the Cook Inlet in particular. And the figure on the right shows a bunch of Cook Inlet volcanoes and the relative distance to the population centers and those little magenta dots showing that population centers are quite close. So the reason being the Western Aleutians have been covered by Yogodinsky, and Mattia is going to talk about the Western Aleutians right after me. And also Central Aleutians have been covered by work by Brad Singer's work. And so the ultimate goal of this is to publish the database as a data release, which then will be added on to the AVO's sort of databases and can be further disseminated. And so, yeah, and be included alongside that GeoDiva refresh in progress. And my slide got cut off a little bit, but it's also going to help inform my own isotopic analysis as I continue my dissertation. So it helps me select different analyses that I need to be redone or are just missing. There we go. There we go. So the information I'm including where it's available is sample information. So the number, where the volcano that the sample's from, also all the reference information, like who's the author, the title of the paper, the journal, the GOI with the link to the publication. So you can just click on the publication, go right there. Also sampling locations, so like the latitude, longitude, all along arc distance as per Matt Lowen's model helped me sort of plot it better. And the isotope ratios as previously mentioned, but also the metadata, which is completely shunted off the bottom. But it's going to include stuff like where they did the analysis, what ratios they used, did they correct for drift, that sort of thing. So it allows for sort of relooking at it and figuring out whether or not the samples are sort of too dated with those techniques and should be redone for modern techniques for sort of reanalysis. And so on the right, you'll see a little thing of the different volcanic centers that I have samples for and the number of samples attributed to those. Some of them have quite a few, some of them have not many. So this has been compiled by hand from the existing literature. So I've just been manually entering them into an Excel file, which has been lovely. So that's why I haven't gotten to tracing major elements yet, because I need to now match them. But the advantages of using the metadata is, as I said several times now, to identify gaps in the available data, like readout has 4. That doesn't seem enough. To isolate analysis that are overdue for reanalysis, like some of the older ones. And some statistics quickly I've got 25 individual references and counting that I've added, 512 samples, 24 analytical duplicates from literature, 37 volcanic centers. But this number I expect to change because some of the names are those old names or they're an individual center that might get sort of agglomerated into a complex. So that's all going to potentially change in the future. And so the oldest analysis we've included is from 1977, Arculus et al. And the newest analysis are unpublished by me that I've done this year at the Keck laboratory at OSU. So, so here's some plots that I just want to show off real quick. Is here we have strontium 87, 86 over the along arc distance. And as you sort of expect, as you go from Eastern Aleutians to the Western, the strontium ratio dips quite severely due to along arc sediment flux differences because terrestrial sediment is enriched in strontium. So as you expected, you have more on the east and less on the west. And I've included some different regions on these to show to provide some context. Like here's from Brad Singer's work, just an unmodified mantle sort of thing. And another one is neodymium over strontium. And you can just see there's quite a bit of variation. I don't have really any interpretation at this point. I'm just showing off some data. And now we have 27204 lead over 26204 with some fields from Yogodinsky et al. And I plotted his mantle morph field and also an Aleutian terrestrial sediment. And you can see that it sort of really plots quite cleanly there. And so I've got some future steps. So I've already came up like a month ago, early April, to grab some samples from the Alaska Geological Material Center. It's quite lovely. You're going to enjoy your tour. I've got about 50 samples in hand with more on the way and a variety of sample types. So I've got bulk rock hand samples, pumice, scoria, mafic inclusions, and also metamorphic xenoliths, which I believe are from spur. And those are gonna be cool to look at. Just have not had the chance yet. And I'm been focusing on a few volcanic centers to do major in-depth projects or more in-depth projects. And then I also have enough sample budget to do some smaller little, more interesting little questions whenever they come up. So I'll be focused on Augustine, Hayes, Iliamna, Redoubt, the Mesopochnoi, and Spur, and see if the pictures come up. Yeah, some fun pictures. And so the ultimate goal of focusing on these particular centers is to ascertain crustal and magma interactions, in the Eastern Aleutians. References, short and sweet. Yeah, any questions?
Matt and I think that Bennett, you're like the gold standard example of best practices of getting samples and data and collaborating, all that. So excellent.
Thank you. Yay.
Thank you.